100 years ago, humanity's understanding of the universe was shockingly limited. Most astronomers believed that everything in existence, the stars, the galaxies, the cosmos itself, was contained entirely within the Milky Way. The notion of countless other galaxies, let alone an expanding universe, was unthinkable. But in 1928, that perspective shattered. Astronomer Edwin Hubble, through meticulous observation, revealed that the universe was not static, it was expanding. Galaxies were moving away from one another, driven by a force no one could yet explain. This discovery forever altered our understanding of the cosmos and our place within it. Decades later, the Hubble Space Telescope built on this legacy. In 1997, it revealed that the universe's expansion wasn't slowing down, as previously thought. It was accelerating, pushed by an invisible force we now call dark energy. Though mysterious, dark energy became central to modern cosmology and led scientists to estimate the universe's age at around 13.8 billion years. But in recent years, the James Webb Space Telescope, JWST, humanity's most powerful observatory, has begun to challenge this timeline, offering observations that suggest our model of the universe may be incomplete. One of the puzzles lies within a dense cluster of stars known as M92, located in the Milky Way. This ancient collection of stars is considered one of the oldest known structures in the cosmos. Some models estimate its age at 13.8 billion years, possibly older. That defies logic. Stars should not exist before the universe itself. Yet, using simulations of over 20,000 synthetic star populations, astronomers found results that placed M92 alarmingly close to the supposed beginning of time. This raised a haunting question. Have we been wrong about the age of the universe all along? James Webb's observations took things even further. It has spotted mature galaxies that existed just 300 million years after the Big Bang, galaxies that appear far too developed for such an early point in cosmic history. According to existing theories, structures of this scale should have taken billions of years to form. So how are they there, fully shaped and shining, at the dawn of time? This has sparked a bold new hypothesis. What if the universe is not 13.8 billion years old, but 26.7 billion years? This theory suggests that our understanding of cosmic expansion, galaxy formation, and stellar aging may be deeply flawed. Some scientists now believe that the timeline we rely on needs to be stretched, perhaps drastically. Then there is the Methuselah star, officially known as HD 140283. Estimated to be around 14.5 billion years old, it poses a direct contradiction to the established age of the universe. A star older than the universe should not exist, yet it does. And it's not just an observational error. This star burns slowly, defying the expected rules of stellar evolution. Its mere presence hints at something deeply wrong, or deeply misunderstood, about our cosmic clock. Another major challenge comes from what scientists call the Hubble tension. This refers to the disagreement between different measurements of the universe's expansion rate. Observations of the early universe suggest an expansion speed of 68 km per second per megaparsec, while nearby galaxies push the number closer to 73. Though small, this discrepancy suggests we may be missing something fundamental. Some now speculate that dark energy itself may not be constant, it might be evolving. And if that's true, it could change everything, from how galaxies grow to how we— These clues, these ancient galaxies that seem too mature for their age, these paradoxes of time and space, and the invisible forces shaping them, have pushed modern cosmology to its limits. They're not just cracks in a theory, they're riddles carved into the structure of reality itself. And they are now driving scientists to revisit an idea once thought too bold, too strange to accept. What if the universe didn't begin just once? What if the Big Bang was not the beginning, but only the most recent chapter in an infinitely older story? This is the cyclic universe hypothesis, a breathtaking vision in which the cosmos undergoes eternal cycles of expansion, collapse, and rebirth. In this model, each Big Bang is not a singular, origin-defining explosion, but a cosmic heartbeat, pulsing at scales beyond imagination. Time doesn't flow like a river from a single spring. It loops like a wheel, carrying all of creation through infinite phases of life and death. If this is true, then the ancient, oversized galaxies observed by the James Webb Space Telescope, JWST, might not be anomalies at all. They could be leftovers from a previous cosmic cycle, luminous echoes of a universe that lived and died before our own began. Like fossils preserved in space, they whisper of ages older than time itself. And that's just the beginning of the mystery. Lurking in the earliest moments after the Big Bang, if it was a beginning at all, are theoretical monsters, primordial black holes. Unlike the black holes formed by dying stars, these behemoths may have emerged directly from raw energy, compressed by the wild physics of the newborn cosmos. Their existence, still hypothetical, could explain how galaxies took shape so quickly. They would have acted as gravitational scaffolding, anchoring matter, creating order from chaos, and fast-tracking the cosmic architecture we see today. If proven real, these objects could unlock secrets not just about space and gravity, but about time, information, and the quantum nature of the universe. They might be relics of a reality before our own, a clue that what we see is only a surface layer of something deeper. And then, we venture into one of the most awe-inspiring ideas ever imagined, the multiverse. What if our universe is not unique? What if it is merely one bubble in a vast, foaming sea of realities, each governed by different laws of physics, born of different Big Bangs, and destined for different fates? A growing number of physicists suggest this could be true. In some versions, neighboring universes brush against each other, leaving gravitational scars, unexplained alignments, or sudden bursts of energy in our own. Could it be that the oversized galaxies spotted by JWST are not even from our universe, but instead, projections, bleed-throughs, or intersections from elsewhere in the multiverse? This theory doesn't just stretch the imagination. It redefines what we mean by reality. To make sense of it, we must look into the most mysterious layer of the cosmos, the quantum realm, where time and causality become fluid. Here, the laws of physics tremble, and even the most basic ideas, like the direction of time, break down. In these chaotic, infinitesimal conditions, especially near black holes or at the moment of the Big Bang, time may have had no meaning at all. Quantum physics suggests that time might not flow like a steady current. Instead, it may ripple, reverse, even stutter in and out of existence. Near black holes, time slows down drastically. In the early universe, it may have glitched, flowed backwards, or simply existed as a probabilistic haze. What we perceive as the smooth passage of time might just be an illusion, a projection of deeper, hidden rules. And so, with every photon captured by JWST, we are doing more than mapping galaxies. We are challenging the very foundation of human understanding. This telescope isn't just a tool. It's a time traveler, a cosmic detective, a storyteller gathering tales written in the starlight of long-dead suns.